My name is Kekana.
My name is Sokhela.
And this is going to be our conversation over the common misconceptions that learners actually have on the topics of mechanics and waves, sound, and light. These learners are failing. Why did they learn this? I thought I told them this last time.
Sorry, Miss.
Sir,
how are you?
I'm fine, and how are you?
I'm not fine. You know what? I'm coming from class. So, as you know, I had to do the introduction. I had to do this thing, Newton second law. Obviously, I had to do the introduction of Newton second law. So, I started with their stating Newton second law, which states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Also show the mathematical representation. So I wrote it on the board. It says F equal to ma, where F stands for net force, and then M for mass of an object, and A for acceleration. That's what happened. But as I came across with the introduction, I find that they've got their misconceptions when it comes to this thing, forces, also masses and acceleration. The first misconception that I discovered is that forces causes motion, not acceleration. Many learners believe that a constant force is required to maintain a constant velocity. The second one is that they think heavier objects fall faster. Learners confuse weight and mass, assuming heavier objects experience a greater what? Acceleration. That's what they have in their mind. Another thing is that they misunderstand net force. Learners think all applied forces add up directly, ignoring opposing forces like what? Friction. So they ignore friction. Then the last one I also discovered is that acceleration is always in the direction of motion. So learners sometimes confuse velocity direction with acceleration direction. So that's what happened when I was in grade 11.
I'm also having the same problem. As you can see, I'm actually marking the grade 10 scripts, and I'm realizing that these learners also have got some misconceptions that makes teaching very tricky. On the topic waves, sound, and light, they actually believe that reflection and refraction are the same thing. As you can look, they don't even understand that reflection is actually when light bounces back from maybe a mirror, and refraction actually means that maybe light is passing through something, maybe like water. Can you even imagine, how do they even start to think that this is the same thing? These learners, they are confusing me. They don't understand which is refraction and which is reflection. And also there's this issue of sound in a vacuum. So many of them think that sound can travel through an empty space. I worry because it's hard to explain that sound actually needs air, it needs water, and it needs a solid to move because it travels through the vibrations, right? And how do I even start to show a vacuum in a normal classroom? Even if I explain it, I still feel that they might confuse it with the light and the sound waves, which can travel in space. I don't know, I just feel worried.
So, Miss, hey, there's this thing that there's challenges that teachers normally face when teaching this topic. You know what happened? Teacher normally face the first challenge that they meet, or one of the challenges, is that the nature of the concept, where learners struggle to connect the mathematical equation F equal to ma. They fail to connect that mathematical equation to real world experiences. Also, their prior misconceptions, like most of learners, they conceive the ideas about motion they also believe, which led them to believe that force is always required to keep an object moving. Then there's also the difficulties that linking theory and experiment. The classroom demonstrations sometimes fail to perfectly show proportionality due to the friction and air resistance. You know. Also, the other problem or challenge that we faced, or as teachers, is that mathematical difficulties. And as you know, we are doing this into secondary. It requires mathematics. So learners, they have weak algebra skills. They find it hard to rearrange the formula and solve problems involving different variables. So as you know, we need to have the skills to solve the unknown variables. They also think the other challenge is that it's concerning about multiple forces acting. Then I find it challenging to distinguish between net force and individual forces. That is another challenge that they do face. I don't know. What about you in the topic? What challenges do they face?
Yes, you're very right. As teachers, we have got a lot of challenges, especially in these topics. The preconceived notions are so hard to correct without clear demonstrations. And this is due to limited props in schools, which reduce the opportunity for demonstrations. Engagement can be very low if lessons is too theoretical and knowledge becomes rote memorization. Not understanding, learners may lose interest if they can't see or hear the experiment, right? So, and this makes it harder for them to grasp the key concept. And I actually feel that diagrams alone are just not enough. The learners will just nod as if they understand, and they won't actually visualize what we're telling them about. So it's so much difficult having to work on these topics as teachers in this kind of schools.
Yeah, Miss. So I'm thinking about the strategies that I might be using when coming across these things, to correct and rectify their misconceptions. Is that the first strategy I'm thinking about is to use of real life examples, where I'm going to relate force to everyday experiences, like pushing shopping trolley. The heavier it is, the harder you push to accelerate. You understand? And then I also use the way I'm going to address misconceptions directly. So that is another strategy to address misconceptions directly. How am I going to do that? By encouraging learners to state their prior ideas, then challenging these experiments, like dropping object or of different masses. Also, the another strategy is to strengthening mathematical skills, where I'm going to incorporate practice in rearranging formulas. As you remember, they are also struggling with rearranging formulas.
The formulas.
So now I'm gonna doing that, rearranging formulas and solving word problems in context. Another thing, the interesting one, strategy is that I'll be using visual representations.
Yes.
Doing overframe body diagram to illustrate the net force and direction of acceleration. So the practical demonstration of which it is the most interesting one.
Most interesting, yes.
The most interesting one. Practical demonstrations and experiments is to do what? Using low friction trolleys, dynamic carts, or air tracks to demonstrate Fnet equal to MA, or showing doubling the force, doubles the acceleration, and dropping and doubling the mass, half the acceleration. But as I'm going to class, I think I need to do some. Here's the ball.
Oh, the balls.
Here's the ball. I think I'll be using this ball. And also this paper. I'll just hold this like this one as it is. Then I think I'll drop them at the same time. So looking, let me see. I'm in class. I'm in class like this, in front of them. Then that's I'm dropping. The one that's reached first, it means it's lighter than the other one, because the higher the acceleration, it means the mass is low. The lower the acceleration, it means the mass
is actually bigger.
It's actually big. Let us see from this one which one have the higher acceleration.
Two different masses.
Already?
Yes.
Okay.
You see?
So you see, okay, the paper. It means as the paper reaches the floor first, it means it has got what?
The lighter mass and the higher acceleration.
High acceleration.
Yes.
So as the acceleration is high, it means the net force is what? Is also higher. So I think I'm going to use
demonstration
this
is good. The demonstration is very good. I'm also thinking about some strategies for my learners, like for this misconceptions. For reflection and refraction, I can use a simple demonstration like a torch on a mirror, right? For reflection, and through a glass of water for what? For refraction, right? So even a straw in water works. I think it really can show the bending clearer. And for sound, maybe if we have a bell jar here at school, I can actually grab that. And I can also use the balloon. I can use a balloon. I do a simple balloon activity. I just tap the balloon and actually allow the learners to feel the vibrations, you know. Yes, and those will be linking it to sound. When they feel it, they can tell, the emotion.
That's
sound is actually traveling, right? And I personally just feel that seeing and feeling these effects, it makes a difference. Otherwise, they'll hold on to the wrong ideas.
Wow.
Okay, so I think we need to plan our lessons more carefully. Like, these learners must just experience this concept. Oh, there goes the bell. It's my period now in grade 11. The learners must be waiting for me.
All right. Yeah. Okay, let me just prepare for another class as I'm going to grade 11 explore.
Okay, sir. Catch you after school.
Okay, good luck with your class.